In this lesson, we're going to cover public key infrastructure, also known as PKI. Now, public key infrastructure, or PKI, is an entire system of hardware, software, policies, procedures, and people that is based on asymmetric encryption. If you've ever connected to a website using an HTTPS connection, you've already been part of the public key infrastructure. Now, if you want to establish a secure connection to a website like DionTraining.com, you would go into your web browser and type in https://www.diontraining.com. Your web browser will then go to a trusted third party called the Certificate Authority, and they're going to ask them for a copy of my web server's public key. Then, your web browser will pick a long, random string of numbers, and it's going to use that as a shared secret key to use with a symmetric algorithm for bulk encryption, something like AES, as we start transferring data back and forth between your web browser and my web server. But first, you have to get that randomly chosen shared secret key over to my web server securely. And for that, we're actually going to use public key encryption known as asymmetrical encryption. Now, using my public key that you downloaded from the Certificate Authority, your computer will then encrypt that random shared secret key that you just randomly created. Now, in the example here, I'm going to use a short number like 51363 as our shared secret. Now, once you encrypt that using my server's public key, which anyone in the world has access to, you can then send it over the internet to my web server. Now, because it's encrypted with my public key though, no one on the internet is going to be able to decrypt it unless they have my private key. And the only person who has that private key is my web server. So, as we go across the internet, no one can see the fact that we're going to use 51363 as our shared secret code. Now, once my web server receives that encrypted ciphertext, it's going to use my server's private key to decrypt it and then get it back to that shared secret key that you submitted. Now I can read the plain text and I know the number is 51363. So far, this is all using asymmetrical encryption like we discussed before. Now up to this point, everything we've done has to do with asymmetric encryption. But now that both you and my web server know the shared secret key, we can switch over and create a symmetric tunnel. Now to do this, we're going to use something like AES to create a TLS or SSL tunnel over the internet and then communicate safely and securely through that tunnel to make sure nobody can see the data you're entering in, like your credit card number, if you're trying to buy an exam voucher. Now, this is going to be able to ensure that we have confidentiality because only we have access to this shared tunnel because we both have that shared secret key. And because my web server is the only device in the entire world that has its private key, you can be assured that only my web server knows who it is and who it claims to be when you sent that code over. This way, we now have authentication. You know it's DionTraining.com. This gives us the identity of my server, and it also lets your web browser know it can trust me. Now, if all that occurs successfully, you're going to get that little padlock in your browser showing that we both can communicate securely with each other over this encrypted tunnel. Now, I know that sounds a lot like public key cryptography. Well, it kind of is, because PKI and public key cryptography are closely related, but they are not the same thing. When we talk about PKI, this is the system that creates the asymmetrical key pairs that consist of those public and private keys that are going to be used in the encryption and decryption process, as well as managing those key pairs to make sure they're valid and can be trusted. When we talk about public key cryptography, on the other hand, we're just talking about the encryption and decryption process. And this encryption and decryption process is just one small part of the overall PKI architecture. Now, for all of this to work successfully, you need to have a trusted third party involved. This trusted third party is known as a certificate authority. These certificate authorities are going to issue digital certificates, and these certificate authorities are also going to keep the level of trust between all the certificate authorities around the world intact. Another essential component of the PKI system is what's known as key escrow. Now, key escrow refers to the process where cryptographic keys are going to be stored in a secure third-party location, which is effectively called an escrow. In the event that an organization or individual loses access to their encryption keys, or in cases of legal investigations, these keys can be retrieved from that escrow account. This ensures that the encrypted data will never be completely inaccessible to us. Now, in the context of PKI, key escrow can be particularly relevant. Let's consider a situation where an employee encrypts sensitive documents using their personal PKI certificates, and then unexpectedly leaves the company or loses their private key. Without a means to decrypt these documents, the organization would be at a significant loss. However, if the encryption keys were stored in a key escrow, the organization could retrieve them and then access the encrypted information. Now, while key escrow can be very beneficial, it is not without its controversies. The primary concern here is going to be security, because if a malicious actor can gain access to those escrowed keys, they can potentially decrypt vast amounts of data. As a result, the storage and management of keys in an escrow must be incredibly secure, and access to those keys should be strongly regulated. Now remember, the public key infrastructure, or PKI, is a framework for managing digital keys and certificates that facilitates secure data transfer, authentication, and encrypted communications over our networks. PKI uses public key cryptography to do all of its functions, but the PKI system itself is an entire system that is going to be used to be able to create a secure connection from end to end. Now, if we're talking about the public key encryption, we're just talking about the asymmetric encryption and decryption portion of this process. But when we talk about PKI, we're talking about everything together. Now, PKI is pivotal to ensure the secure communication and data exchange that happens on the internet, and components like key escrow are going to provide us with additional layers of flexibility and assurance, but they also introduce their own sets of challenges that we must manage effectively to ensure the security of our enterprise networks.